HP multi-jet fusion technology produces fast, quality functional parts with best-in-class isotropy at a low cost per part. Unlike the slow-point processes of some current technologies, HP multi-jet fusion technology's proprietary area-wide processing achieves quality part production at speed. The process begins by applying a layer of material in a work area. In the opposite direction, in one continuous pass, we print fusing and detailing agents across the full working area. This pass combines the printing with the fusing energy, and the process is then completed. HP's proprietary architecture is capable of printing 30 million drops per second along every single inch of bed width, enabling precision and dimensional accuracy. To produce truly functional parts, it's important to ensure that the material has been properly fused and that part edges are smooth and well-defined. To achieve part quality at speed, HP invented a multi-agent printing process. In this process, a fusing agent is applied on a material layer where the particles are meant to fuse together. A detailing agent is applied to modify fusing and create fine detail and smooth surfaces. The area is exposed to energy, and reactions between the agents and the material cause the material to selectively fuse together to form the part. The fusing process requires accurate temperature control across the entire material layer. HP Multi-Jet Fusion's closed-loop thermal control system does this by measuring temperatures at hundreds of points on the material bed. This information then determines which areas receive more energy to raise the temperature and which areas are cooled, allowing for control of thermal bleed and layer-to-layer fusing and cooling. The result is full control over mechanical properties, dimensional accuracy, and repeatability. The process is then repeated until a complete quality, truly functional part has been formed. This is how HP's proprietary area-wide processing compares with existing popular point processing technologies for building functional parts. In the time it takes slower point processes to build one part, HP's multi-jet fusion technology can produce functional parts in a fraction of the time. Using HP's proprietary multi-agent printing, HP Multi-Jet Fusion technology achieves new levels of part quality with uniquely predictable print times for any type of part to drive optimized production and design freedom. In 3D design and printing, a voxel represents a value on a regular grid in a three-dimensional space, like a pixel with volume. By controlling the properties of each individual voxel through agents, HP Multi-Jet Fusion can produce parts that can't be made by other methods. Taking advantage of HP's in-depth knowledge of color science, HP's 3D printers could, in the future, selectively print a different color at each volumetric pixel. A single 3D printed part could have literally millions of colors. But more than just full-color printing of functional parts, HP's multi-agent system enables a fundamentally different approach that could unlock the full potential of 3D printing. At each voxel, HP transforming agents could control surface texture, wear, and friction, enabling single parts with multiple textures, or the monitoring of part performance. The transforming agents could control the translucency of each voxel, enabling the printing of lenses or sensors. We could also optimize the strength and stiffness in portions of a part and print elastic voxels in other portions of the part. The conductivity of certain voxels could also be controlled, enabling embedded electronics. HP transforming agents could also be used to enable the printing of new advanced materials or enable emulating different materials at each voxel. HP's multi-jet fusion technology could enable design and manufacturing possibilities that surpass the limits of our imagination.